Hello everyone. Today I'm going to show you a new JavaScript framework I've been working on called OVR that's built to help you stream HTML declaratively with asynchronous generator JSX. OVR is designed to optimize time to first byte. It evaluates all of your components in parallel and then streams the resulting HTML in order using an asynchronous generator that feeds right into a readable stream response. So components are written similarly to React. You have a function component, and for this component, OVR would generate three chunks of HTML. So we have first the opening paragraph tag, then the content, hello world, and then finally the closing paragraph tag. So in this example, it's pretty trivial to stream this, but once you get into asynchronous components, you can see where this might be useful. So in this case, we have an asynchronous component called username, which gets the user and returns the username, maybe from an API or something that has some latency. And then this username component is used within our other component to give a personalized greeting message. So in this case, OVR, instead of waiting for username to resolve before sending this component, it will immediately send this opening paragraph tag and the text hello to the browser. Then we'll await this promise and get the user information, send the span and the username and the closing span tag, and then finally the closing p tag. So each component is literally streamed as it's created on the server. This allows your server to render exactly how browsers read your HTML. Web browsers are built for streaming, and HTML is a very robust language that allows browsers to paint and parse HTML as it arrives. So you can get a partial rendering of a page before you have all of the HTML content. Most critically, the head of the document is useful to have arrive as quickly as possible because you can start requests for the other linked assets before the rest of the page has finished streaming. So I've got an example here. We make a request to the chat path of this application, and we get an HTML response. This total response takes about a second to complete, but you can see the head of the document was streamed in around 50 milliseconds. So we get the JavaScript and the CSS that are required for this page before the HTML has finished loading. This allows the browser to have all the resources it needs before the page has arrived and gives users a faster experience because they don't need to wait the total time of this page and then also the round trip time to get these linked assets. OVR gives you true streaming server-side rendering out of the box. There's no client-side JavaScript involved. It just delivers the HTML in order as soon as it's ready. Next, I'd like to take you through how you can get a project going with OVR pretty quickly. It's pretty versatile. You can use it in a variety of different options. I've got a package called Domco, which allows you to easily set up a server with Vite. And then I've added an OVR framework option to the create script. So that's what I'm going to do to get this project set up real quick. So if you're installing it manually, you'll need to add the following options to your TypeScript configuration to enable the JSX transform. TypeScript, v, ESBuild all pick up these options from your tsconfig. So you'll need to tell it to use the React style JSX, and then our JSX import source will be OVR instead of React. You can use OVR in any Fetch API compatible runtime via the app.fetch method. There's a variety of ways to do this. I think Domco is a pretty easy way to get this going with Vite, but there are lots of other options. You can use the Cloudflare Vite plugin, or you can kind of roll it yourself with Node plus the new ServX package from the UnJS team, or you can use like Dino or Bun with their built-in HTTP servers that are already fetch compatible. And here's an example of that. So let's get into how the components work. Components are authored similarly to frameworks like React. There are two main distinctions between OVR and other frameworks. The first being OVR only runs on the server. So there's no client-side runtime for OVR. And the second one is that JSX evaluates to an asynchronous generator that yields escape chunks of HTML. So let's get into what all of that means. If you aren't familiar with basic components, there are functions that return JSX elements. You can use them to declaratively describe and then reuse parts of your HTML. And you can pass arguments into them with props. And this is just kind of a convention. So you can write a component as a function with props, and this is an object with various properties inside of it. And then you can use those properties within the template of your component. So just like React or Solid, if you're familiar with those frameworks. And now the component can be used as its own tag with a capital letter, and any children will be passed into this children prop. All HTML attributes are rendered as is, so you don't need to use camel case for HTML attributes if you're using OVR. So if you're coming from React, you'll need to use the class attribute instead of the class name attribute, for example. Components can be asynchronous as well. So for example, you can fetch directly in a component. What will be sent to the client is only your HTML template, so you don't need to worry about this component also being rendered on the client. It is only rendered on the server. Components can also be generators, so you can have more fine-grained control and actually help you optimize your memory usage as well. You can use generators to yield values instead of returning values. So here's an interesting example where we can see we render 5,000 different divs using a generator instead of a map. So in this example, you have an array that you create of length 5,000, and then you're mapping over that array. So in effect, you're creating a new array of different div elements. So in OVR, you can just use a generator instead, and you can yield these divs as you create them. And that will send them immediately to the client as they're created. So if we refresh the page here, you can see all of those divs streaming in order as they're created. And this doesn't require any sort of optimization on your end or any client-side JavaScript. This is just HTML being sent as it's created. Next, we have parallelization. These components, they all await in parallel when components are evaluated. So under the hood, OVR uses the promise.race method to evaluate components all in order, and it will yield components as they are created and queue the ones that come later in the page when they are complete. So say in this case, we're rendering username, generator, and data. All of those would kick off their processes at the same time. And once username is completed, it would be streamed and so on. So if data completes before username, it will be queued and then sent immediately. And we can see an example of this here. We have all of these different delays that are created using this delay component. So each delay is 100 milliseconds longer than the next. And you can see we aren't getting the total time added up between all of these components. Each one is simply streamed in 100 milliseconds after the rest instead of the total stack time. As far as return types, so you can return or yield most data types from a component. They're tried to match what React does for different data types being rendered as you might expect. So if you yield kind of these null, undefined, false, true, primitive values, you'll get the empty string. And then for other data types, you kind of get a stringified version of what you would expect in there. You can also render functions, and it will return what the function returns, whether if it's async or synchronous. If you'd like to check out the source code for how all of this works, the package is pretty small and fairly readable, so you can see the JSX transform here is just over 200 lines and get an idea of how OVR generates each of these components. You can render HTML directly by using the chunk constructor. So chunks are what the async generator actually produces and uses to escape the HTML inside of each chunk. So if you create a chunk with the second argument set to true, it will not be escaped and just render the chunk as it is. You can also run components independently. If you're using the app, which we'll get into next, you won't need to do this directly most of the time. But if you need to just evaluate a component separately, you can use either the toGenerator function or the toString function. So the toGenerator will create a generator from any component or really any primitive, whether it returns JSX or a number or whatever you're returning. And then toString will basically buffer all of toGenerator into a single string. So it's better to use toGenerator when you can to take advantage of streaming. So getting back to how you use OVR, at the core of it is a web server that you can create with a new app instance. So it works similarly to frameworks like Hono or Express, if you're familiar with those, except for there's some built-in handling for the OVR JSX components. There's a few configuration values. You can customize your trailing slash redirect, your not found handler, your error handler, and then your base HTML, which you can use to inject your components into, which we'll get into shortly. So at the most basic level, you can return a web response from an API endpoint, and that will generate a new response for you. You can also return JSX, and that will generate an HTML stream response. So as we were looking at before, this would generate a readable stream, which streams in the H1 tag, then the hello world text, and then the closing H1 tag after that. And this element will be injected into your base HTML. You can use app.get and app.post to create handlers for different HTTP methods, and you can add other custom methods with app.on. You can add multiple patterns. If you add multiple patterns, both with different parameters, the parameters will still be type safe, so you can see exactly which route is being used in that case. And middleware works similar to Koa Compose. So if you're familiar with Koa or Hono or Express, you can get an idea of how middleware works. So you have a list of middleware basically, and each one can be called. And if you call await next within that middleware, it'll dispatch the next middleware in the chain. So this makes it easy to chain different things together. So in this example, we can log one. We'll dispatch our next middleware, which will log two, and then that one doesn't dispatch any more middleware, so then we'll resume our order up here and we'll log three. The same context is passed in between each middleware, so in this case, we're just using the C variable, and you can do different things using the context, so getting the request URL and constructing your response. You can add global middleware using the use function. And then finally, the fetch method on the app is kind of your entry point for your application, which you can pass a new request to and get a response from your application. So this is how it plugs into Bun or Dino's HTTP server. There are also a few helpers you can use to encapsulate a route, which allows you to easily create a route in a separate module outside your app. So this makes it easy to keep the actual route pattern and your logic for that route in a separate module from the base app module. So you can create a get route, and this will automatically create a corresponding anchor, button, and form component for your route. This ensures if you change the route's pattern, you don't need to update all the links throughout all of your applications. So in this example, you can see we'll import get from OVR. You can initialize a new get and return hello world from that. So this is basically saying app.get and then the first argument being slash. And this will also create a link for this route, a button with a preset form action and form method attributes, and then also a form for this route that you can use throughout your application. And so say you change this pattern to hello, then all of those components would also have that new pattern used to create those components. There's also a post helper that does a similar thing, except for using the post method. So this one's particularly useful. You can use the form that's associated with this post method within maybe a get handler, and then you can post directly to this form using that component. You can use the add method, and this will register one of these helpers to your app. So You can add a single get helper, you can add an array, you can add them as an object, and any combination of those kind of works. This makes it really easy to create a module of helpers. So you can create a get route for a certain module and then a post route. Maybe those two go together, and you can export them from that module, and then you can import them um, as a namespace. So you can say import stars home from home. And then if you do app.add home, it'll add all of these helpers to your application, and you don't have to register them one by one. Here's some other properties that are also present in these helpers. So if you have the following helper for get, so as a name parameter, you'd have all these methods and properties also available to you. So middleware is just an array of all the middleware. The params is a type helper to get the actual type. So you have name here, and if you do get.params, then you would get the name uh, param type. The pattern, which is just the exact pattern that you use to create the route, well, the path name is the resolved path name. So in this case, we have name. You can use the path name function to pass in the name world and get the precise path name of the route. And if you pass in the params as consts, you'll get the exact type back, or you can get a fairly close type without as consts as well. This ensures if you say update get to a different param or you use the wrong param. So in this case, if we tried to use ID instead of name, we would get a type error because that's the wrong parameter being passed into our path name. So getting into context, here's how you would access the context and everything that's available on it to help you create your routes. So you can access information about the current requests, such as like the URL or the params of the route. You can build responses with the context. So similar to Hono, this is modeled after Hono. So if you do c.html, you'll create an HTML response with the content type header of text/HTML. And so those are kind of helpers so you don't have to write the content type header for different responses. There are also page builders. So say you need to set the title of a page, you can use the c.head helper, and you could pass whatever tag you want inside the head of the HTML into that c.head helper. So you could pass some meta tag or a title or different things like that. And then you're able to inject elements into the head that will be streamed first. And then you can also create a layout and use c.layout, and you can have however many layouts you want to apply to that particular page. And this is just middleware, so if you want to apply a layout globally, you can use app.use and apply it globally as well. There are also some other utilities available on the context. So you can memorize a function, you can generate an e tag you can use for caching, and then the build method is the internal method that builds the final response after all of your middleware have run. The last helper is the get method, which is a static method on context, which allows you to get the context from any component that you write. So you don't have to necessarily be within a middleware handler to write your component and access that context thanks to async local storage. So you can import context and call the static get method, and then you'll have that context within your component. And this will ensure you're only accessing that context in the scope of the current request and not leaking into different requests. Uh, and you have the correct information based on the exact request that you're handling at that time. OVR uses a try router, so this ensures that performance doesn't degrade as you add more routes. It's forked and adapted from the Memoirist package and the Medley router package. So if you're familiar with those, it's based on those. It's similar to other routers. It has support for params, wildcards, and then routes are prioritized static first, and then the parametric, and then the wildcard routes. You can also use the classes to create your own router if you want to. So let's get into a basic example, and I'll pull up the application here. So here we have our app created with DOMCO and OVR together. So what DOMCO does is it'll give you the transformed HTML from your client application as a string. And we're going to set that equal to the app.base. So if we go in here, this is what our base looks like. And we can just remove all this content here and basically just get the head and the body, and that'll be our base that we want to inject tags into. Next, we'll create a new page. So in this case, we can return anything, and this will be our streamed HTML. So I'll just return the OVR docs link here, and then we'll add that page to our application and then export it from our plus app.tsx entry point that DOMCO creates for us. But this could be your Dino server entry point or your bun or your node with servex, any of those that support the app.fetch method. Um, that is what we're using to serve our application. So if you're familiar with this export default and then having a property of fetch on there, that's exactly what we're doing here with app.fetch. So you can see we've got our link created there based on that. So let's just build out a simple page here for a demonstration. So next I want to just demonstrate some basic streaming with OVR and what you can do to stream HTML elements. So let's make a little delay helper here. And we can use this to create an asynchronous generator component. So let's make a new component. And we're going to make it a generator using the star syntax. And in this case, we can yield values to generate different things. So we could yield hello. And then when we use our component here, that will generate hello. So let's put it in a paragraph tag. And then we will await our delay. And we'll need to make this an async generator in this case. And then we can yield maybe another paragraph that just says done. So you can see when we refresh the page, that's getting streamed in. And you can see that just disabled JavaScript, and that's slowly streaming in 500 milliseconds after, just using this asynchronous generator. So you can see it's really easy to create streams declaratively with OVR. So next I'd like to just give our page a title. So we can use c.head and we'll give it a title. And let's just call it OVR. And you can see we've got that OVR title set for this page now. Next, let's add a post handler with a form. And let's just have it return JSON. And now what we've done is we've created a post helper, and we can use that post helper within our get wrap. And if I put a button here, and if I remember to add the post to our application, when I click on this submit button, we'll see that we have the status equals success. And what's interesting about this, if we remove the pattern, OVR will actually generate a pattern for us based on a hash of the middleware provided. We can also create this post route with parameters. So let's say we have post and then we want a name in there. You can see that, hey, we need to say which parameter we're using to submit this form. And you can see params, and then actually on that params object is the name property, which we'll need to pass in. And now we have name. Let's just return our name here as well. And it's all type safe, so we have name right there. And now when I submit, we'll have post Ross and our name is Ross. And you can also do the path name, and that will require me to pass in the name as well. And that will ensure, so say we update this to ID instead, you can see we're getting type errors every place we've used those parameters, and that we need to update this to ID instead. So those are the basics of using OVR to create a website. Let me know what you think in the comments. Give the repo a star if you enjoyed it or want to try it out. Feel free to create an issue if you have any questions or find any bugs. Looking forward to getting feedback on the project. Thanks for watching. Have a great day.